Dear students, see the next question from 11th standard unit and measurement Ncert exercise problem 2.20. So see the question. The nearest star to our solar system is 4.29 light year away. How much is this distance in terms of parsec? Okay. So 4.29 light year per second la kekranga first question. Next, that how much parallax of the star named Alpha Centauri shown when viewed from the two locations of the Earth 6 months apart in this orbit around the Earth. Okay. So first என்ன கேக்குறாங்கன்னா 4.29 light year தொலைவுல ஒரு ஸ்டார் இருக்கு. That is nearest star in our solar system. Okay. So yes, that is the nearest star. That name is what? This Alpha Centauri. There is GK question also. Okay. Right. So that 4.29 light year means what? Say for example, now I can observe one star. For example, now I will observe one star. Okay, this is a star. Now I will observe the star. It is from the Earth. Okay. So now I am here. I will observe the star. This light. Actually, now I observe the star. I receive one light. That light 4.29 light year. Okay, 4.29 light year. 4.29 light year. That means approximately 4.29 years. And the year start ஆனது. Okay, 4 வருஷத்துக்கு முன்னாடி ஸ்டார்ட் ஆனது இப்போ நான் பார்க்கல. Okay, so that means how much distance. First you should calculate how much distance, then should calculate into the parsec. Okay, so see that actually the given distance value, that is a 4.29 light year. So 4.29 into 1 light year. So 1 light year is equal to 1 light year means what? Light traveling distance in one year. So it is 1 second, 2 seconds. Per second 3 lakh kilometer. Like that 1 year. So light traveling distance in 1 year, that is 9.46 into 10 power 15 meter. This much distance. So 4.29 light year. So 9.46 into 10 power 15. Okay, right. So this value already I calculated. That is a 4.058. 4.058 into 10 power 16 meter. Okay, so actually the 4.29 light year is equal to this much meter. Okay, then this value we should convert as a parsec. So this distance you should convert into parsec. So parsec, the parallax plus that second, that is angle. So if the parallax angle is 1 second means that distance that is 1 parsec. So now we can calculate this value into the parsec. How the given value, how to convert it into the parsec. So we know that 1 parsec value. Okay, 1 parsec value. 1 parsec, that is 3.09 into 10 power 60 meter. 1 parsec. Okay. So now I can write 3.09 into 10 power 16 is 1 parsec means what about 4.058 into 10 power 16 meter? How much parsec? Okay, so meter will be cancelled. So the 10 power 16 will be cancelled. So the remaining value will give that one. This equivalent parsec value. So that value also already calculated. That is 1.318. 1.318 per second. So that means what? 4.29 light year is equal to how much per second? 1.318, or approximately I can write 1.32 per second. Okay, so it is the first question. Okay, so 4.29 light year is how much per second? That is the first question. Right. The second question, okay, see that. Show when viewed from the two locations of the Earth 6 months apart in its orbit around the Sun. Okay. Say for example, now it's the Sun here. Okay, it is the Sun. Okay. Now you know it is the Earth. Okay. Now the Earth is here. Okay, or otherwise, okay, now the Earth is here. After 6 months, the Earth is here now, opposite end. Okay, now let us imagine that star. Okay, now that star is okay. So now the star is here. Okay, actually it is very long distance. Okay. Listen. So we know very well it is very long distance. The star is now very long distance. Okay. So now let us imagine. So now I have to view this star from here. Okay. So now, okay. Now I view this star. So it's a first view from here approximately. So first view from here. Okay. After 6 months is one more view. Okay. So now this is that it is that angle theta. Okay. Now what about this value? This distance. What is this distance? So actually it is the Earth. This is Sun. Okay. So very well the average distance between the center of the Earth to the center of the that Sun. That is 1.496 into 10 power 11 meter. That is 1 astronomical unit. So approximately you can write 1.5 into 10 power 11. So here 1.5 into 10 power 11, here 1.5 into 10 power 11. So I can write this is 3 into 10 power 11 meter. Okay, so now we are going to find that angle. Okay, so you can write the angle theta by using the parallax method. That is a base divided by the distance. So base is nothing but what? There is a diameter of this orbit. Okay, right. So now, this orbit, that's a diameter. That is a 3 into 10 power 11 divided by the distance. The distance. Okay. So which distance? It is the distance. Okay. The light traveling distance in parsec value, that is 1.32. Or otherwise, this in meter. So we can write 4.058. Yes, 4.058 into 10 power 16 meter. 4.058 into 10 power 16 meter. Okay, so that theta is equal to, if you simplify, I can get already I calculated. This is 4 approximately. There is a 7.4 into 7.4 into 10 power minus 6 radian. So this is the angle. So this angle value, that is a 7.4 into 10 power minus 6 radian. So this is the angle. Okay. So now distance, it's a distance d. Okay, it is a distance d. Okay. So this distance value, that is a 1.32 per second. Okay, or otherwise 4.058 into 10 power 16 meter. Okay, so now they are asking the angle of But they didn't ask in what is it, radian in terms of radian, in terms of minute, in terms of second. Generally asking, so our convenient I can calculate it as a radian. Okay. So by using this kind of idea, we have to. It is a basic research for about astronaut. Okay. Thank you.